Hello, my name is Thomas Rintoul. I'm not a third year astrophysics student. I have just finished my third year of astrophysics at the University of St Andrews, and welcome to week four of my summer project. So I'm doing a summer research project with one of the academics in the School of Physics and Astronomy here in St Andrews, and I'm working on a supernova feedback simulation. It is week 4, as I just said, and I am making progress, maybe? I don't know. I think, over the past few weeks, I have learned how to... Well, I've read a few papers about supernova feedback and the work that is being done here. I have learned how to run simulations in a program called Phantom, that we're using to varying degrees of success. I have tried writing my own programs, figuring out how to influence the particles in the simulation, and I have discovered this morning that half of it doesn't work. Yeah, we're off to a great start. Today is Monday the 28th of June 2021, and I've got 3 weeks left to figure out what the hell I'm doing. I've got a meeting at some point today with my supervisor. I've just had an email in. It might be saying, hey, can we meet at this time? But yeah, I'm making some progress, perhaps. What I'm currently trying to do is create a simulation that adds both kinetic energy and thermal energy into a gas cloud where supernovae are happening. The problem is that I can't seem to get both of those to happen. I can get thermal energy on its own. I can get kinetic energy on its own. I can't get both at the same time, otherwise it either crashes or is slow as balls. It actually says that on the board there under the bugs that I currently have to fix. The other bugs I've still got to fix are the fact that it doesn't appear to be inputting enough energy, which I think I've solved because I discovered it's not putting in thermal energy, or it's putting in very, very, very little thermal energy. The other thing I've discovered is, well, the other thing that I'm pretty sure is wrong, and I'm not sure what's going on, is that it's injecting supernovae in the wrong place. But currently the fact that it's not inputting enough energy is the bigger problem. Also the fact that it is very slow. Like, I've been running this current simulation for about 5 minutes and it's not even done one supernova yet, and it should have done about 30. So I think I'm gonna have to kill that and figure out what the hell is wrong with it. Yay. Anyway, I need to go and read that email. I will check in with you guys probably towards the end of the day. If not, then actually maybe tomorrow. I'm trying to get less footage for these because at the minute I've got far too much to cut down, and I'm trying to give you the core details of what it is I'm doing. I don't have any fancy renders for you at the minute because, well, it doesn't work, and yeah. Anyway, I will check in with you guys later. Hopefully you're all enjoying this so far. If you're new, make sure to subscribe and comment below with any questions you might have. Cool. I will see you later. Bye. Okay. It is now 4 o'clock, and I've had a meeting with my supervisor. He's been away for a week, but he's back now. And we've had a wee discussion over what we've been doing in the program. We're trying to kind of iron out the bugs. Now, the current situation we've got is I have a simulation that seems to be failing at doing one thing. Well, no, it can do one thing on its own. It can do another thing on its own. What it can't do is both at the same time. We want both thermal energy and kinetic energy in the same simulation, and to get both in the same situation is proving difficult, to put it mildly. Currently, I am in an attempt to try and get it to work. There are a couple of options we turned off that used to be on, so I'm going to turn them back on again and see if that was causing the problem. One is independent time steps. So the sort of simulation that I'm running is something called a smooth particle hydrodynamics simulation, which is Lagrangian, and you can give different particles different time steps. And I think that this is the problem, that independent time steps not being on was stopping the whole thing working. So that's what I've turned on now, and I'm going to see if I can make it work. So currently what I'm doing is compiling the program. The reason that you have to compile these programs is because they're written in a programming language called Fortran. Now, Fortran is something a little bit different from something like Python, which a lot of people may be familiar with, in that it's a language that has to be compiled before it can run. So basically it goes through the entire program, finds any errors that there might be, and it compiles it all into one program that you can then run. This method of compiling a program before you run it makes it incredibly fast, different from Python, which is very slow by comparison. The downside with that is that you have to compile it every time you want to run it, and it can take a little time if it's a big program. Currently it's looking like I haven't fixed the problem. The problem I have is that these numbers are going far too slowly. Like, this should be done by now and it's just chugging. I don't really know why. So that's kind of where we're at the minute. I don't know what's wrong with this. I'm going to email the postdoc and say, I've discovered these problems. Any ideas? Because this is kind of game breaking if it doesn't work. Good morning, it's Tuesday and I'm excited. Yeah, basically I emailed the postdoc in the group last night and said, I'm having all these problems, it's not working, it's giving me stupidly small numbers. And then he was like, you know that this thing, VXYZU4, this like fourth thing in that list, you've got X velocity, Y velocity, Z velocity, and then internal energy, which is like thermal energy. He said, you know that specific energy, right? So like energy per mass. So you might have heard of specific heat capacity, which is the amount of heat you need to put in to change 1 kilogram of a material by 1 degree Celsius or 1 Kelvin. Yeah, specific energy is kind of like that in that it's the amount of energy in a material per unit mass. So in this case, it's ergs per gram, and erg being 1 times 10 to the minus 7 times a joule, and a gram being a gram. I don't know why we use these stupid units, but we do. But apparently that's how it works. It's specific energy, not intrinsic actual normal energy. So that's what I was changing all of my specific energies to intrinsic energies, and that doesn't work. I need to divide all of my energies by the mass. So that's what I'm doing now. I'm running a simulation at the minute. I'm 17 supernovas in out of about 30. Yeah. I can't believe that I've spent like a week making this mistake. I'm really hoping this has fixed it. If it's not fixed it, I'm gonna cry. Yeah. Today's off to a good start. We're gonna ignore the fact that I couldn't sleep last night. It wasn't even just that I was being lazy. I just couldn't sleep. So I had slept in this morning because I didn't get to sleep until like 4 AM. Oh, thank goodness this is a flexible working thing. Like, as long as I do the work, I don't really care when I do it. I could do it at 2 AM for all they care. Yeah, it's a fun time. I'll see you guys later. In fact, I might see you guys in a few minutes if this thing's worked. I'll show you the render. Cool. See ya. Anyway, I think it works! I actually think it works. I've got things that make sense! Somehow. I will show you what I've currently got. Now, the thing that makes me think it's working, before I show you the render, is the graph that I have produced of energy, both thermal energy and kinetic energy. I have got this. Now, on the top we have kinetic energy with time, on the bottom we have thermal energy with time, and the jumps are where supernova happens. The reason I think this is working is because this view is extremely similar to the view that we got from, not view, but like the plots we got from the Balsara and Kim simulation. And that's the one that I know works. Like the decay patterns and everything makes sense, which means my simulation might be working. What I've done is I've added back in individual time steps for the different particles, and I've added back in H2 chemistry. Actually, have I added in H2 chemistry? I might not have added that in yet. Oh no, I've added back in H2 chemistry. So it's, the chemistry makes more physical sense. So I've added all that stuff back in, and the thing works. So let's have a look at the render. So we start off with the uniform distribution. We get these 3 supernovae that get set off. We then start to see a few more happening. Now, the initial pattern isn't quite as homogeneous as I would like it to be, but it's just a quirk of the code. And we get more of these going off. Now, they look less impactful than they did before, the initial ones, because we're starting to have supernovae that, while they're happening in some regions where there are denser particle numbers, there's also quite a lot of rarefied regions, the bluer regions, where there are fewer gas particles, which means there's less ability to carry that energy off. Now, I'm not convinced it's working entirely correctly on the setting them off in the right place, because we're still getting this really dense band, this really dense filament structure. But I don't think that it's too wrong. I think that the actual physics of it is working mostly correctly. So that's the plan. Well, that's not a plan, that's the result we've got. We've actually got a result, and I'm kind of astounded. I've got to email this to my supervisor. All it took was being told, hey, you notice specific energy, right? Not normal energy. And that fixed the whole damn thing. It's really nice knowing the rest of my code worked. It was just that I missed out a divide by mass of type I gas. It's like, all I had to put in was / mass of type, open brackets, I gas, close brackets. All I had to add and the whole damn thing worked. There are going to be refinements I can make to it, but oh, I'm so happy right now. I'm so glad that worked. Right, I need to go and email my supervisor and say, hey, I got it to work. Good afternoon. So it's now about 4 o'clock, but here is where I'm going to end for today. Now, before you start thinking, oh, well, it's like 4 o'clock, how was he managing to finish up early? I can't do anything else today. I've got a working simulation as far as I am aware. It's run at 32 resolution on my computer. The problem is that I need to know how well it runs at a 64 resolution. And I'm not doing that on my own computer. When I want to run the simulation at a higher resolution, I've got to offload that to the university's computer cluster, which I've done. I sent it off to the Kinetic computing cluster at the university and said, hey, run this. And it's been running for 45 minutes. It's only about halfway done. So I can't continue any further in my project until I know if this has worked at a 64 resolution or if it's completely broken down. So I can't really do anything else for the rest of the day. I've got some other things I need to be getting on with, so that's what I'm going to do. I'm going to get on with the other things that I have to do that aren't related to the project. So I guess I'm finishing work at 4 o'clock. It's fine, it's totally fine. This thing, I've actually made a lot of progress today. I've made more progress today than I have in the last week, which is amazing. And I'm looking forward to getting the renders tomorrow morning of the new simulation. Wonderful, cool. So I will see you guys tomorrow, where we will hopefully have a nice, lovely render at 64 resolution with the new data from cluster at the university. I'll see you guys tomorrow morning, and goodbye. Good afternoon. It's Thursday. I'm realising I didn't actually film anything yesterday. Apologies. It's also the afternoon on Thursday. It's about 3 o'clock. I've done no work on the project today because I don't know why, but my sleep schedule at the minute is a bit screwed. Like, I can't get to sleep, which is proving a little problematic. I didn't get up until about 11 o'clock today just because I could not get to sleep till about 4. I'm really hoping this subsides soon. I cannot keep this up. The reason I've not done any work yet in the last 4 hours is largely because I've been very busy. Because today, with it being the 1st of July, I'm now officially the school president for physics and astronomy. And I had a load of emails to send and things to sort out and plan and everything, and it's been a bit of a wild ride. I used the mass messaging system for the first time, the system that lets me email the entire school, which was pretty fun. Well, interesting. It didn't send it immediately. It was like 10 minutes later. I was like, is it actually going to send? But it's fine. It was just slow. I've got in contact with the director of teaching for the school. Just say, here's what I'm going to be doing for the next few weeks. Here's a couple of things that I have questions about going forward. Here's a couple of things you should know about. If you have any questions, get in contact with me. What else did I do? I got in contact with the school presidents for maths, chemistry and philosophy because we have what are called joint degrees. So like you can do physics, or theoretical physics and maths, or you can do physics and chemistry or physics and philosophy, and that could be your degree. You do modules from both schools. We have a class rep specifically for joint honours students, these people doing these joint degrees. But the other schools don't, and it's been mentioned that it would be helpful if they did, because there'd be somebody on the other end of the line whose entire job is to liaise with the other schools and solve problems for these students. I've updated the Facebook page. I've done a lot of basically the admin things at the start of the day. But what did I do yesterday? Well, yesterday I got all the information off the Kennedy computers, the computer cluster at the university. All the data that I'd been running a simulation for on Tuesday afternoon. And I'm very glad I gave up about 4 o'clock because that thing took 3 hours to run. I got all the information off it, and my simulation worked. I'm not entirely sure, but I'm not entirely sure how I managed it, but it works. I know I've done it. It's just surprising that it worked. I've been asked to send some stuff to the postdoc because he thinks what I've done could be useful for him. I've got some other stuff to do to expand the work that I've done So that's what I'm going to be working on for the rest of the afternoon. And yeah, it was a really exciting time. Like between over Tuesday, Wednesday, I've made more progress than I made in the week leading up to that. The next thing I think I need to do, if I remember correctly from the email I read, is that we want to start off with working from a turbulent box rather than a uniform distribution. So we've got like gas that's been already a bit whipped up and then go from there. So that's the next job, is to do that. So I'm going to go and send off the emails that I need to for my project, not school president stuff, and get to work on that.
Good morning. Happy Friday. We are on the final day of the week and I'm waiting on simulation running. This is becoming a recurring theme. Quite unsurprisingly, molecular clouds in space, where stars form and where supernovae happen. They're not a nice box of uniformly distributed particles. They have some structure to them. They have some turbulence to them. And I wasn't simulating that yet. So the next thing I need to do is to simulate that and get that to be a thing that we can consider. Problem is, I don't know how to set that up. At the minute, I'm trying to run a simulation that might work. I've tried amalgamating two setup files to make it work, and at the minute I'm testing it to make sure that adding stuff in hasn't broken it. So I'm running it without adding in my supernovae, but I've added a load of other stuff in as well into the setup file, and I'm making sure that they haven't broken it. That's running at the minute, and it's going so slowly I could, once I got a decent number of dump files, I could start looking at visualizing it, and it looks like it's still working, so I haven't broken that part. So yeah, that's where we're at the minute. In the meantime, because I'm, a nerd, new Critical Role this week, so I'm watching that while I wait for the simulation to run. I will give you a bit of an update once that's run and hopefully not broken itself. Well, I say broken itself, hopefully I've not broken it. And yeah, I'm hoping to get a bit more work done today because, well, I didn't really get much done the last couple of days. Okay, so that's us got to the end of week 4. I've got remarkably little done this week, that's why the video's been quite short. But actually I see we've got remarkably little done this week. We got quite a lot done. So we've obviously got the now working kinetic energy and thermal energy simulation. That now works and I'm quite happy with it. We've now got the next steps as of this afternoon. I now know what I'm doing with the next steps. I've been given converging flow simulation, so a lot of gas is allowed to sort of self-gravitate as far as I can tell, and I've been asked to start working on putting my simulation into that. We've got a bit more internal structure before we start putting in the supernovae. So I've got that simulation working, the internal structure without the supernovae. I know how that evolves with time, so that's fine. What I need to do next is figure out how to implement my simulation, so adding in my supernovae. So that's the next part that I've got to do, but that will be a job for Monday. This evening I'm going to eat some pizza and then I am streaming Space Engineers over on my Twitch channel, which if you're not following it, you definitely should. Although by the time this video comes out I might be away on holiday, but either way I will be returning to streaming if I'm not streaming when this video comes out. So yeah, if you've not done that yet, go check out link in description below. Right. I will see you guys next week to start adding a supernovae injection stuff into a collapsing gas cloud. And yeah, have a good weekend. See ya. Actually, hang on, if you haven't yet, like, subscribe, comment, all the stuff you know how to do. I've just assumed you know how to do it because I forgot to tell you. Right, now I'm off. Bye.